All good.
Okay, hello everyone. My name is Artem Mygaiev. I'm from EPAM Systems, and we have Stefano.
Hi, I'm Stefano Stabellini. I work for Xilinx.
We both are heavily involved in Xen Project. I think Stefano much more than myself, but for the last few years, I'm also into that. And sorry. Today we'll talk about the approach we're taking in Xen Project to make it safety certifiable, not just a fork, but make a mainline of Xen safety certifiable. First of all, a few words about Xen. Xen is a type 1 hypervisor. We have very flexible virtualization models. It's fully open source. It's part of Linux Foundation project. We work with other projects like Linux kernel, Zephyr, and other LF projects. We also collaborate with Linaro, obviously. In general computing, Xen is maturing since 2003 and very widely used. Not so much as an embedded. It has support for latest Arm Next 6 cores. We have very low defect density on coverage. It's like 0.38 per thousand line of code, and even those are mostly false positives. That's for ARM build, not for x86, excluding tools. And Xen already has some multiple safety applications historically in avionics, aerospace. There are some projects in automotive and military for pure safety or aerospace, or for mixed criticality applications as well. Previously, Xen was certified, not the mainline, but some forks. It was done by some companies with safety-trained engineers. For example, there was the 0178 DALC certification for aerospace. And according to the people familiar with the method, it was like 5 to 15 years for one-off certification. Some time ago, when we started to look at certifying the mainline, we thought like how to minimize the scope of that. And talking with the guys who were doing it, we understood that, of course, the effort with such forks, at least, effort heavily dependent on code size. So we wanted to minimize the code base, including only stuff that we really needed. So we understood that we want to we cannot spend and certify all of the Xen, and we want to certify some minimal. Mostly we target ARM. Stefano was one of the authors of initial ARM support in Xen, and we understood that it's totally doable to have a 50,000, something like 50,000 line of code of minimal Xen on ARM be certified, but we couldn't understand if it's maintainable. We didn't want to make it like one shot or branch certificate or force certification, and we want to understand if it's possible to do it in FOSS model. So a couple of years ago, we established a Xen special interest group for safety certification. Leaders were Arm, EPAM, Xilinx, some assessors participated, Exida, David from Mira was there, and TÜV as well had reps. All Xen project leadership team supported. Kate supported us as an observer and advisor, and we had some industry representatives, some companies participating there. Sorry? Yeah. On this in this group, we agreed on some high-level agreements. Like there was some clear benefit. Well, Xen itself is not only used in safety, and mostly it's used not in safety. So non-FuSa community also needs to have benefit. We need to have some split development model between open and closed part. We shall not introduce any uncertainty why some specific changes are needed. So community must have a full agreement. And we don't need to change any workflows in open source model, or the changes shall be minimal. We don't want to create a parallel universe of Xen, so we need to use Git and make everything centric to Git, and we'll talk about that later on. And again, reiterate, everything we do for safety can be only done if there's agreement to implement changes in code, which is common. Well, community itself cannot be accountable for safety, so we agreed that there will be some commercial vendors who will be accountable when they release Xen as a product. It can be, I don't know, integrators or whoever else. And we agreed to do partnerships with like this with Lisa. So basically, we work closely with Kate and with Zephyr. Again, we'll talk about it later because we want to have Zephyr as a DOM0 OS to control Xen, and also we share some documentation ideas with them. On certification, we obviously want to certify Xen as a safety element out of context, and we cannot go at least at this point, anywhere higher than ASIL-B. So on this work scope for the special interest group, we wanted to understand and eliminate group gaps in documentation, in processes of validation verification, establish the infrastructure, including tools for documentation, maintenance, and testing. Maybe do some changes in Xen code to implement more deterministic behavior, fault processing, add some defensive programming techniques, and support certified tools, and have safety management processes in place. Again, that it also falls back to tools. Yeah, so first, on the requirements and documentation, Stefano.
Yeah, so it's very important for the documentation is one of the most important part of safety, and part of the documentation is really the B model, which is everybody doing safety is really familiar with it, but and it has to do with the process of writing high-level spec, which goes then into more detailed spec again, into low-level design eventually, and in the code itself. And then you go up again from more details into lower level detail, into higher level of abstraction with the tests. So the same way you go from the high level specs down to the low level design and then the code. From the test, on the test side, you go from smaller unit test to system test and to wider acceptance test. That gives you the so known as a B model for the documents.
Yeah, on Xen, if you look at what we have, which artifacts we do have on Xen, it's mostly like high-level specs. We do have low-level design in mailing lists and everything. Of course, we do have code and very basic tests, like the stuff that we run, like core system and other, which are system tests and can be, some companies do acceptance tests. So basically, if you look at the traditional V model, we do have gaps on documents, and we don't have any traceability, so we don't match the sides of the V model. So if you look at what needs to be done, we need to map high-level specification of acceptance test, system spec and the system test, and so on. So basically, we need to have a full coverage for the requirements and tests, and we need to have a traceability between those. And obviously, that's not something that traditionally exists in open source community, right? So yeah, Stefano, you probably can cover this part better than me on the requirements side.
Yeah, so it's very important to write on the documentation side, to have clear requirement and ambiguous requirements, and in fact they should be written in a way so that the test can be written just out of the documentation. Now, that is very important because it changes really the attitude toward documentation in general in the project, because documentation is not just, as typically is done in open source or in most projects, I would say, to document an already existing behavior of the code. You are expected to write first the documentation on the behavior, on the interfaces, on what it should do, right, the requirement. Then you're supposed to write both the code and the test, but that can be done in parallel, can be done by different team. And in fact, you don't even need the code in order to write the test. So the documentation is supposed to be in detail and high quality enough so that the testing could even be written before the implementation itself. So this is obviously a very high standard to live up to, but it's what we're gonna strive to achieve. Yes.
Yeah, and one point that we also wanted to have is the linking between the requirements, code, even existing code, and the tests, and that kind of traceability is something that obviously will be a must-have from certification authorities. And again, that's something that doesn't exist, and we need to implement that. And yeah, where it can.
So
yeah, please.
Yeah, so we've been discussing a while, because typically this documentation and this requirement, the linking between the documentation and the code, is maintained in large proprietary tools on purpose. I mean, written on purpose and sold to do safety on software projects. This is a bit unworkable for a couple of reasons in an open source setting. First of all, nobody, I mean, not everybody will have access to the tool. While here, you know, everybody will need access to the tool. But in addition, if you worked on an open source project, you probably know that everything is on Git, right? If you have things that are on Git and also somewhere else, typically they go out of sync. It's not really easy to maintain things that are not inside the repository. So after many discussions, this is where we came to the conclusion that really the best solution is to keep the requirement, the document, and the linking, so everything mentioned so far, inside the repository itself. Why? Because that is the only way we have to keep things up to date, to make sure everybody has access to it, both maintainers, contributors, really everybody, and also that we can make sure it's kept always up to date with each contribution, even from external people that don't necessarily know about safety or about safety processes. We can still make sure that this documentation and the linking are kept up to date. So the idea is to use text file to use RST files, Markdown, keeps them inside the repository itself. To use tagging for linking between, so special little tags to link requirements documents with high-level requirement document, with the design document, and with the code itself. And then use open source tools such as Xen, in fact, Xen specifically, to generate the documentation in the format that a safety accessor would be expecting it out of all these documents inside the Git repository.
Yeah, so
yeah,
please.
go ahead.
No, please go.
No, go ahead, Artem.
So basically, right now, we did this. We reused the stuff that was initially developed by Zephyr. We were like having initial implementation of these of documents implemented in Xen. We are again agreeing now on terminology and creating some first examples, and I think we've had a pull request from Bertrand or someone from his team already on some pages on these documents. I'm not sure if it's went in or not.
It's still under development. Yeah.
Yeah. Also, some time ago we did if there's already a huge code base that exists in Xen, and we wanted to understand what can we extract from the mailing list on the requirements on the implementation to document the existing code. So there are like tools like cregit that are linking code and documentation. But if there are like versions of patches and notes from code reviewers, and there are RFCs, and sometimes things are getting split or combined into same series, cregit cannot catch that, and initially it supports Linux kernel only. So what we did, we ran, we did a git blame for the whole code and ran it against the NoSQL database like Markmail, which allows us to build a very sophisticated queries and then parse it. And applying very basic fuzzy logic, we could cover up to 90% of code with emails, with the whole series of emails leading to the particular commit. And we were able to catch threads from the very beginning of Xen ARM in 2012, like for the initial pushes, and even further. Like I've seen things that were not covered. The only things that were not covered, initial very big first Cambridge work by Ian Pratt and Fraser, in Cambridge even before Xen name was introduced. So basically, we can cover existing code, most of it. Of course, it will require human work on cleaning up, but even that will be a very huge support on creating both requirements and implementation documents, and also building like who approved it, who committed it, who was author, and so on. Yeah. So a few words on process mapping. Safety relation require formal processes, definition, and so on. Actually, Xen is other open source, many other open source projects has very rigorous definition of change management, release management, somewhat documentation management, but mostly in terms of like what has to be done when you are submitting a new page, how to describe it, and so on. We try to map existing process to define to ones defined in ISO 26262, like for example part 8 or others, and 12207, which is referenced by ISO 26262 and others as a generic process definitions. We wanted to identify gaps like verification, obviously not very formalized or not formalized at all. And we understand that there must be there shall be some new processes to be introduced, most related to safety requirements, like management of safety requirements, certification, and so on. And we want to do this somehow with minimum disturbance to community. So we started with mapping existing stuff. As an example here, I'm showing the change management. This is part of some of the requirements of ISO 262 and how it's defined in existing procedures of Xen. Obviously, those need to be extended, or in some cases it's defined but not very much formal or split in several documents. But basically, with all of that, we have very well covered change management. With some things are missing and some things are just needing minor cleanup. We did a very first review of that. This is like just to show that even process documentation exists in a very good form and doesn't need to be like completely rewritten, just need to be adapted and mapped into in regulations requirements.
Misra-C. So Misra-C is a set of safety guidelines for software written in C. So there is a set of guidelines for software developers to write safe software in the C language. And it's divided in rules and directives, where typically actually Misra-C used to have only rules, but rules are for the code itself, like write code this way or that way, avoid this pattern or use the other pattern. While directives are a bit more wide-reaching, and they're not just about the code, but also about the contribution model and the whole process. They're not strictly the code only. Rules and directives are divided into 3 broad categories that are mandatory, required, and advisory. Where mandatory, they have to be complied with. There is no room for discussion. Required are rules and directives that shall be complied with unless there is a deviation. I'm going to talk about deviation in a second. And advisory rules are are less formal rules and directives to follow, more like suggestions, good to follow rules that are not strictly required. So deviations. So normally, when we do safety, we try to follow as many rules and directives as possible. But any project is always the case. There is always 1 or 2 that maybe they cannot follow, or maybe they don't apply because they do something else that makes them irrelevant or not really the right match. In these kind of situations, we write deviations, and a deviation and an explanation of why one of these rules does not apply, or why we're doing something else instead of following the rule to the letter. As you can imagine, deviation is an important part of writing the deviation in the proper way and deciding what are acceptable deviations, which one are not, is an important part of the Misra-C compliance. Another part of Misra-C compliance, which is really key, is a static analysis tool. So Misra-C is a rich set of rules, as you can imagine, and it's difficult to remember them all by yourself. So this is why you use typically as a developer or as a reviewer of code static analysis tool to help you identify Misra-C violations. This is particularly important, as you can imagine, in an open source project where there are a number of contributors that might just stop by to send a patch once and never again, and that maybe I never heard of Misra-C or any of the safety practices. So it's particularly important to be able to identify Misra-C violations for contributors as well. So the first thing we did with Xen is to, and this was Resif Tech that did this work. So we did an analysis on the number of Misra-C violation of Xen as is, without changes, without fixes, nothing. And the results are here on the slides. But the key message is there weren't that many violations, especially once as we start looking into them and we realize that the top 5 or 6 that you see in the picture on the bottom left were actually all false positive. So actually, you know, if you ever use a Misra-C checker, they're really difficult to configure correctly in order to avoid false positive. And the reason is because you have to inform them of all the assembly function you might call, or about some certain header file. You need to make sure that all the header files are properly traced. So it's very easy to, without an appropriate configuration, to stumble across a high number of false positives. But the point is, especially taking into account false positives, then the number of outstanding Misra-C violation is actually quite low. So what are we trying to do right now? In collaboration with Zephyr, and Zephyr came up with a short list of Misra-C rules that are relevant for the project. This process is called tailoring, you know, looking at Misra-C and finding the right set of things that apply to your project. So Xen is quite similar. So we are going down this list and analyzing which one of the rules make sense also for Xen, and how to automatically check for them. Like as mentioned, automatically check is a very important part of the picture.
So Stefano, I suggest that we skip going through particular rules, and I can just show where we are. It's very small. Basically, we are going through the rules and checking what can be done, if it's applicable for Xen, and which tool can be used. But that work is not yet complete.
We're about halfway through it.
Yeah. Some rules can be checked with the GCC keys. Some can be used with checked with CPP check, and even that need to be validated if that really checks, or maybe it misses something, or maybe there are false positives or something. Yeah. So maybe that's a pure technical. We have for mixed criticality implementation of Xen, we have come up with some configurations of certifiable Xen. One is like traditional Xen boot. We want to, when everything is, including Linux, is in DOM0, and there are all of the dependencies, which is very hard to comply with FuSa, and hardware has a single point of failure. We introduce a concept of DOM0 with RTOS. That's where we can use Zephyr, and we are now discussing. We are now discussing implementation of Excel and some other tools to have a proper license and safety compliant implementation. So we eliminate dependency on DOM0 Linux, the whole DOM0 Linux system. We also have a concept of DOM0-less.
DOM0-less was introduced originally for speeding up the boot process, but is also very useful because it's a parallel boot where DOM0 is not necessary or used to start additional VMs. They are started directly from Xen after loading those binaries from the bootloader. But this is very useful because also you can set up a system this way without DOM0 or with a DOM0 that does not much, right? And therefore doesn't need to be safety certified. So if you go to this next slide, Artem. yeah, so you get shorter boot times and an independent DOM0 that then maybe can even be stopped, or maybe doesn't need to be present at all. This is what sometimes we refer to true DOM0less, in the sense that DOM0 is actually not there, right? You don't start it even. So if there is no DOM0, then there is no DOM0 to safety certify, and that obviously lowers the amount of lines of code that needs to be safety certified at the end.
Yeah, we also do some work on making Xen more deterministic. I'm not going to cover that in very much detail because I think we have some 4 minutes left. That maybe there are questions, but basically we are able to achieve very nice numbers on real timeness, if you like, of Xen scheduling, and there are other approaches like cache coloring. Yeah.
So cache coloring is a technique in Xen to split the cache by allocating in a very smart way the memory for VMs, so that they end up using independent L2 cache lines. By splitting the cache, you have a lot more deterministic performance, both in terms of RQ latency and in terms of also execution times.
Yeah.
So the determinism is greatly increased.
Yeah. So yeah, that's very basically it, and I think we can move to questions.
Yeah. So I see a question about Doxygen. So Doxygen reads in-code comments. So comments inside the code itself. This is very important because that's how we document interfaces. I think it also reads RST files, if I'm not mistaken. Or so it's not, this is the format is similar to Markdown, but not quite Markdown. And then it generates HTML out of them. So that's from HTML, you can also very easily generate things such as PDFs, and that's the output format you would expect to present to the safety assessors. So cache coloring. So cache coloring. Sorry, not going in order. Just so cache coloring today is implemented for ARM. However, most of the code is actually not ARM specific. I would say that maybe 80–90% of the code is not ARM specific. So it would not be very hard to port it to x86 or RISC-V or other architectures.
There's a question about Misra. Yes, we want to apply it to the whole Xen project, except probably user space tools, which we don't see any value at the moment. And
yeah, so everything on the Xen Hypervisor, so that would be the Xen directory.
Yeah, on Zephyr, yes, we want to use it as a save DOM0 as a reference save DOM0, because there may be also commercial RTOS systems that can be run as a DOM0. But since Zephyr is open source, we can have a commercial, well, let's say reference implementation of that. And again, since Zephyr is targeting safety, I think Kate can comment on this better than me. We do want to use it as ASLB safety element out of context.
Awesome. So many interesting questions. So will you use only open source tools for Misra-C compliance? So obviously, when there is an open source tool, is easier and is preferred for a number of reasons. I mean, we are all open source, supporters here. In addition, it's also a lot easier, right? Usually, it's a lot easier. You don't need to get a license. Otherwise, we need to go through the Linux Foundation to get a license to the tool, to deploy it. Is actually difficult, even if we wanted to deploy. And we might have to end up using proprietary tools, especially for Misra-C checking. So we have already identified a few of the rules of the shortlist we were talking before that cannot be checked today with CPP check or GCC or other open source tools that we know of. So we might have to either resort to a proprietary tool or extend one of the existing open source checkers. Yeah,
most probably we'll have like both, like for wide community to be able to commit, even for those who are not really interested in safety, to check the code. We can use open source tools, but for certification, we obviously will need to go for compliant and assessed tools. On the Zephyr transition, so far we are implementing current PV support. Verta.io on ARM, and expect some patches coming. Zephyr project initial support for Xen already implemented. Now we are implementing like event channel for console and for managing Xen itself. This will be done by event channels and like current implementation. Vert.io currently being developed for ARM actively. Last release we've got merged the IRAC server for ARM, and now we are collaborating within the community to have more things implemented, like block device network, the Vert.io standard devices. This is going to be published pretty soon. The initial implementation of block device was already published, I think, in winter.
So likely both are going to become available soon, or they're already available in a prototype form.
Yeah. Safety element out of context documentation is not yet available. And I'm not really sure. We have not yet finalized agreement on which part of the safety documentation going to be publicly available and which won't. We don't know yet, because some of that will require, investment to fund assessors' work and so on. We don't really know how this will. Maybe it will require some cost. We just don't know yet.
I think we are out of time. So if there is one last question, or probably it's too late. So thank you everybody for your participation and for listening. So if you are interested, we have a mailing list and bi-weekly meetings. So feel free to join, and we'll discuss it more.
Yeah. Thanks everyone.
Thank you, guys.
Thank you. Thank you.